So this is problem number 71, and problem number 71 is here. The random variable x is uniformly distributed between 0 and 4. The random variable y is obtained from x using y is equal to x minus 2 squared. What are the CDF and PDF for y? So we need to find the CDF and the PDF for y. Given y is equal to x minus 2 squared, and we are given the what you call x is uniformly distributed between 0 and 4. Uniformly distributed between 0 and 4. So uniformly distributed between 0 and 4 means this will be the function. Between 0 and 4, if you have, the value will be, the value of fxx will be between, x by 4, okay, x by 4. And the what you call the PDF, this will be the CDF, this will be the PDF, which will be 1 by 4, 0 less than x less than 4. Remember that this will be a triangular function in the uniform, what you call, whenever uniform distribution is given, the CDF will be the triangular function and the PDF will be the squared function. This we have already seen in the what you call, what you figure over here. Yes. Yes, this is the figure. You can see that this is the PDF, which is a square type or rectangular type, and this will be a what you call ramp in that for the case of the CDF. And the equation for this will be what you call when it's distributed between 0 and 5, this will be x by 4, and between what you call 0 and 4, the PDF will be 1 by 4, because area here should be equal to 1. Area for fxx should be equal to 1. 0 to 4, length is 4, multiplied by 1 by 4, height will give the area to be 1. So y is given as x minus 2 whole squared for us. So when y is this, then x minus 2 will be plus or minus root of y, and that will give us x is equal to 2 plus or minus y. So fyy will be equal to p of y less than y, and this y is, one can write it in a different way. Okay, this y of y will give us the value in a different way as, so to say, between. So this will be equal to p of x less than x, where x is between these two values. P of y less than y will be equal to p of x less than x, and that will be between these two values. That is there are two values of x over here, 2 plus of root y and 2 minus of root y. So from 2 minus of root y to 2 plus of root y will be the range of values of x over here, right? So therefore, here it is that function which we are trying to write, 2 minus of root y less than x less than 2 plus root y. So that will turn out to be fx of 2 plus root y minus fx of 2 minus of root of y. And that will give us, if you try to differentiate this function, you'll get, if you what you call differentiate the CDF, you'll get PDF. And if you differentiate this, you'll get the PDF with respect to that, but we need to write the internal derivative of that. That will be 1 by 2 root y. Similarly, if you write the differentiation of this, that will be same thing with the internal derivative of this. Internal derivative of this will be minus of 1 by 2 root of y. Minus and minus will cancel. Therefore, that will become plus. So therefore, we can just, take that out over here. You can join these two over here. So we will get here, 1 by root y. In the bracket, you'll get fx2 plus root y plus fx2 minus root y. Okay. So the value of fx2 plus root y will be equal to 2 plus root y by 4. Okay. This value will be, we know that if fx of x will be equal to x by 4, and that will give you 2 plus root y will be equal to 2 plus root y by 4, and that will be between 0 less than 2 plus root y less than 4. And if you try to solve this, you can take this 2 on this side and 2 on this side. If you take 2 on this side, it will become minus 2. If you take a 2 on this side, it will become 4 minus 2, that will be plus 2. So thus, we'll get over here, fx2 plus root y will be equal to 2 plus root y by 4, and the range of values here will become 0 less than y less than 4. Similarly, when fx of 2 minus root y, if you want to try to write it, then that will be equal to, again, x by 4. X is nothing but this quantity over here, 2 minus root y by 4. But the range of values is between 0 to x, 0 less than x less than 4, and x is nothing but, 2 minus root y over here. So again, you take this side here and this side here, you will get minus root y, minus 2 and 4 over here. And if you try to solve that, you will get, this inequality will become, this one, because if you throw out multiply by minus, then this 4 will come here and this 2 will go there with a minus sign. So it will become minus 4 less than y less than 2. So this will get converted into this. So that will give us the value, what you call, between these two as, okay, we don't know why I have written this. Okay, just check this up. Okay, so this value will be the value here for this range. And in the earlier one, we have here 0 to 4, 0 to 4. So that is 0 to 4. And this is, if you just take the square of this, right, that will become, minus 4 whole squared will give you 16. 16 is very large, and this will give you y squared, root y squared will be giving me the value 4. So we cannot take negative values. We take 0. We cannot take negative values. 16 has no meaning over here. So this will be 0. And if you square this, that will be 4. That's why it is written as 0 less than y less than 4. Okay. So overall, the range of this y and the range of that y will be same, and we'll have to write f by y. In the earlier expression, f of x of y will be here, this quantity over here, this as well as this we need to write. So if you write this, you will get the term over here like this: 2 plus root y by 4 minus 2 minus root y by 4. That will be root y by 2. And in a similar way, we can try to write the, what we call PDF. That will be 1 by 4 between 0 to 4. This will be 1 by 4 between 0 to 4. And if you substitute that, you will get here 1 by 2 root y 1 by 4 plus 1 by 2 root y 1 by 4. And if you try to solve this, that will give us the value 1 by 4 root y. 1 by 4 root y. This is how we can get the value of the 71. So let us go for the, problem number 72 now. 72 is written over here. Resistor R are uniformly distributed in the interval 50 plus R minus 5 ohms from the circuit theory for conductance. G is equal to 1 by R. Okay, this is resistance. The conductance is 1 by R. What are the CDF and PDF for G? So we need to find the CDF and PDF for G, not for R. Okay, so let us try to go through the solution for this. Okay, so FRR is equal to, 1 by 10, 45 less than R less than 55. That is because the value taken over here is 50 plus R minus 5. So one side 50 minus 5 will be 45. Another side 50 plus 5 will be 55. Okay, and it is uniformly distributed. So between 45 to 55, the total range will be 10. And that means the length of that will be 10. So height should be 1 by 10. Length of that should be 10. Therefore, height should be 1 by 10. That is why we have here the value 1 by 10. And this is within the range 45 to 55 and 0 otherwise. Okay. So if you integrate this, you'll get R by 10, 45 less than R less than 55. Okay. If you integrate 1 by 10, you'll get R by 10. And if you integrate the, what you call PDF, you'll get the CDF. So now, since G is equal to 1 by R, since G is equal to 1 by R, you can write f of G of G. F of G of G is what we can try to write. right, is equal to f of r of 1 by g. Okay, f of r of r is nothing but 1 by g. F of g is equal to f of r is equal to 1 by g. So f of g will be equal to, now in place of r, we need to write 1 by g. So in place of this r, we need to write 1 by g. Hence, we will get the what you call cumulative distribution function for the what you call conductance as 1 by 10g, and this will definitely be, the range also is going to change because now we have to write for g, not for r. So r is between 45 and 55. So g will be between 1 by 45 and 1 by 55. Which is smaller? 1 by 55 is smaller. Okay, here 45 is smaller and 55 is larger. Whereas if we take the inverse, 1 by 55 will be smaller, 1 by 45 will be larger. So therefore, we need to write the other way around over here. 1 by 55 less than g less than 1 by 45. 1 by 55 less than g, 1 by 45. So if you take this, now if you differentiate this on both the sides, you'll get the probability density function of g. If you differentiate this over here, okay, so you'll get fr of 1 by g, fr of 1 by g into, internal derivative of this, that will give us the value minus 1 by g squared. Internal derivative of 1 by g will be minus 1 by g squared. So then we can substitute this fr of 1 by g, and fr of 1 by g is what we have, uh, f, so to say, the value f of r of 1 by g is what is written over here, right? So this should have been, I think, might be the same thing as fr of 1 by g. So we need to write over here, and we'll get, 1 by 10 g squared, 1 by 10 g squared between 1 by 55 less than g less than 1 by 45. Okay, so we need to substitute over here the quantity which corresponds to fr 1 by g. Okay, fr 1 by g, right? Fr 1 by g can be what you call considered from here, right? R is not there over here. We'll have only 1 by 10, and this value will be just 1 by g. So naturally it will get converted to this, and then later 1 by g squared minus 1 by g squared is multiplied to it, and hence we will get the value here as 1 by 10 g squared, 1 by 55 less than g less than 1 by 45 over there, and 0 for the rest of the thing. So f of g by g is nothing but fr of 1 by g. Fr of 1 by g is, in place of r, we should substitute g. There is no r there, only a constant 1 by 10. So therefore, 1 by 10 into minus 1 by g squared is what we have, and hence we are going to get this. Putting a negative value is of no meaning here because this is a PDF. Therefore, we have put here the positive value. Therefore, we have put here the positive value. Now, let us go for the problem number 73 now. Okay, 73 is given over here. I think we will stop for today. We'll continue in the next class.